gno.land is a layer 1 blockchain that can be comparable to Solidity. Both have capabilities of smart contracts, but they have their own syntax and specificities. While Gno is inspired of the Go syntax, Solidity has a custom syntax specialized for blockchain. Let's compare the two environments and let's explore some common patterns of the two languages. As to note, this video is oriented for Solidity developers. In this video, you will learn exactly the comparison between the two languages, the common patterns, and the best practices. I will refer some videos in the description to start your gno.land journey. Gno is a blockchain platform using Go-based smart contracts. Its language is the Gno, and it is interpreted, so it is not compiled to bytecode to compare it with Solidity. It enables to store the entire contract, even with the command for documentations, for a more open smart contract system. Gno as Go has a very strong static typing, so not having the good type won't make you able to execute the code. There is no Go routine in contracts, which may be added in the later futures, as quoted from the documentations, and you can find persistent state with realms. The whole philosophy of Gno is to write a smart contract system that is familiar for the average Web 2 developers that are already developed in Go. Since Go was all made to be a simple language to learn, it is quite straightforward, even though it is less specialized than Solidity. Most of the code you will do in Go will also work in Gno. You have also access to all the tutorials in Go to learn the development. To compare the features between the two languages, so as said before, the base language is custom and Golang. Execution is compiled to bytecode and other one is interpreted. So in Solidity, you must upload the code in alternate providers. Both type system is static. Solidity has an inheritance system, while Gno has a composition system. It is a more straightforward approach. Both have interfaces and they have different error handling I will show right after. And they both use gas, so EVM and Gno gas. So let's start with the basic counter patterns. So we cover 16 different patterns that are all available in the descriptions. I will update them whenever there is a need. There is also readmes and you can execute them quite easily. I will show at the end of the video. So to start off easily, in Solidity, you must create a contract object which will act like a class. It will contain variables and functions. You can define some modifiers, so you can see here public, view, returns with a returns type. So it means quite easily that public it can be accessed by anyone. So view means it's not gonna modify the contract. So in that case, increment is gonna modify the inner variable of the contract. And returns define the return type of the functions. So in that case, get counts return an unsigned int 256. Gno has a different approach. It has a one package, one contract. So one package can be made of multiple files. As long as they are in the same directories and they have the package counter at the top, they will be in the same smart contract. And variable of the contract can be defined as global variables. To note, there is no unsigned int 256. The maximum size is this size. It is still possible to use structure or other formats to store bigger numbers. And there is no modifier keyword like you have in Solidity. You directly type your functions that can be accessed to your contracts. And after you can execute them. Some small details you may have noticed. The curl realms means it's gonna cross into the smart contract. It is a defense against reentrancy attack. I've made a complete video about it in the descriptions. In simple terms, you can imagine each contract as an isolated code, and by adding curl realms, it will be defined as accessible from the outside. So any outside functions calling increments can modify the contents of the smart contract. So now to set any field as private or publics, in Solidity, as we saw earlier, we have the public and private keywords. You can set it on variable or functions. There's also external, which is only accessible from the outside and not from the inside, which is some little optimization to use less gas. And Gno uses an implicit syntax, where if you have an uppercase letter, it will be public, and lowercase private. There is no such keyword as external or internal in Gno. So to explicit, private means it's only being accessible from the inside of the contract and public by anyone. Now an interesting pattern is to own the contract. So specific users have more rights on the contract. It can be some root operations, like an upgrade for example. In Solidity, either you made yourself or you can use the OpenZeppelin ownable contracts, which can be imported this way. And you will use inheritance to be able to access the modifier only owners. Each function with only owners will be only accessible by the owners that's being defined. In that case, it is the message sender. It is defined during initializations. In gno.land, we have the ownable package from the new tendermint directories. This is the core team directories. And during initialization, you fill the ownable objects using the new with origin functions. Init and constructor will be executed by the one that's at the package. So it will be the message sender in that case. Or in that function, it will be hidden, but it is the origin caller. And even though we don't have any modifier in GNO, you just have to call the functions as turned on by previous to be sure you can execute these functions. While in Solidity, you just have to add the only owner modifier. State lock is a simple pattern that lets you set the contract as a specific state. So it can be open, close, pause. It can be also for functions. In Solidity, you will create an enums and an attribute state. You will create a new modifier that can be called in the modifier space. So here we verify the state is still open. And in GNO, we're gonna create an enum this way. Iota means the next variable is gonna be incremented by 1. So this one will be 0, 1, 2. And we create a function's assert states. Overall, any modifier you want to use in GNO is a function you will call at the beginning of your other function. Mapping lets you do dictionaries. In Solidity, you use the mapping keywords with the types. And in GNO, you use the AVL tree. Biggest difference is Solidity have explicit type, where AVL tree has implicit type. So you must always use a string on the left, and any type of the right you must cast every time you use it. A cast is done by dot parenthesis type, and both are used these different ways. To emit an event, Solidity, you must define the event and use it whenever you want to use it. And in GNO, you must call the chain.emit functions with the different variables. You can put any string and it will generate a data structure like a JSON that can be parsed by any listener. A factory pattern lets you create a number of new objects, so like a contract, using a simple functions. Solidity is much more permissive than GNO. As in GNO, you cannot create a new contract if you're not a user. In Solidity, we have two contracts. Create contracts, create a new object contract here, and push it in the list of address we store in the contract factories. While GNO, we're waiting the contract to be already registered. In Solidity, we have two contracts. Create contracts, create a new object contract here, and push it in the list of address we store in the contract factories. While GNO, we're waiting the contract to be already registered to then register it in the list of contracts. Token is quite similar. You have also an OpenZeppelin package. I didn't include it, but we have the same formats. It is called ERC20 and GRC20. So G for GNO and E for Ethereum. This is a very simple ERC20 because it's missing some fields, but you just have to implement the interface basically. Transfer, min, get balance off. Exactly the same for GRC20. There is some example for both on the internet. There's some detailed variable that lets you interact with your GRC20 tokens. I will let you check the GRC20 video I've made in description. Reentrancy guard is a protection, so your contract is only accessed once during your executions. So let's say you withdraw monies, you will lock it using requires and locked, and you will unlock until the end of the withdrawal. So if at any time in the between we recall withdraw, it will just panic, since this function can only be called once. In GNO, we create the functions too. It is set as public, but it should be private. And we use the defer keyword, which will let this function to be called at the end of the execution of withdrawal. So it means the last instruction of withdraw will be the unlock. All the next patterns are going to be a bit more complicated patterns. So take your time to check out the codes. This function lets you able to deposit some money in a contract. In Solidity, you will just get the value of the message.value and you will just update the balance. In GNO, you will use the bankers modules, which lets you use any kind of other coins as GNOT, which is the origin coins. You can create your own coins for the contracts, and the users may be able to send any of them. So we get the values sent by the contracts, and the send variable may be any kind of coin, so we must verify it is a GNOT. In our case, we didn't do, so that may be a security exploit. But normally after verifications, we can take the amount of the good coins and we can get and set the balance. It is a bit more advanced than Solidity, but basically it is the similar code between the two. To withdraw some money, you will do the reverse operations. To send the coins, you will use the payable color transfer amount. So very straightforward. And in GNO, you will use again the new bankers, and this time you will use a type realm send, and you will send coins using the address of your own contracts, the colors. This is the denomination. You can put different coins if you want to send different kind of coins. If your contracts have different denomination, if you create a native coins, and function after are the same. A guard check is a modifier. Basically, you set a modifier, you put it right in the modifier field, and in GNO, you put it at the beginning of the functions. A proxy lets you able to upgrade your contract in the long term. So you create an interface with the different functions executions. So you create an interface with the different functions, as much in Solidity than in GNO. And during your execution of executes, you will just execute the functions of the implementations you will store in your contract. At any time you can upgrade it, and it is exactly the same format in GNO. You can also use delegate call in Solidity. All this kind of call is not possible in GNO since it is less permissive. Stop the contract, we use enable in both, and we just verify if we are with a state lock. So it is a mix between other stuff we saw earlier. And speed bump verify the time to check if you didn't call the functions early enough for a single users. There is the block timestamp, which is the timestamp of the current block, and you can do some comparison. In GNO, we have the time package, and we can do some operations, and if the time is incorrect or like too early, we can panic. And last but quite important, I will show you the difference between inheritance versus compositions. In Solidity, you can call the is other contracts. So enable is another contract. So it implements all the functions of enables as the modifier is on. And composition, you just add the variable in a structure that you can call, and you can add functions, override the before methods, and set some specific method. Key differences between the two: message sender equal runtime previous realm address, or it is more origin color in that case. Require is a panic. Modifier is a function calls generally with assets at the beginnings. Mapping is AVL tree. Emits events is chain.emits with any information after. Contracts is realm and pure packages, which have no state for pure packages. Constructor is init functions, and message.value is banker origin send. The best practices from GNO. So think packages, not contracts. Each directory is the packages, so you can take advantages of it. You must use composition over inheritance. Any standard library in Go must be implemented in GNO. So check out the already made efforts in Go. Use AVL tree for mappings, not simple lists. It is much more efficient. Generally panic for errors instead of continuing a wrong executions. You can return error types that can be taken by the caller. The two are right, but generally it is better to panic to avoid continuing with a wrong state. Realms are stateful, so persistent state across the different calls. Of course, if you change some values inside. And there is no dynamic dispatch, which means GNO needs to know precisely the type and what it's gonna execute before deploy time, while Solidity can be at runtimes. It can call a function and later the caller to set it, which can be quite dangerous but powerful. And remember, GNO is Go, so if you know Go, you're already 80% there. Patterns are similar, just different syntax, and community is helpful. Don't hesitate to join the Discord. You can ask questions at any time. I recommend you to read the next step if you want to get in it. To execute any of the snippets, you must go in the GNO versus Solidity in tutorials. I will set the link in description. And you must do test snippets. You must put the numbers of the snippets. So it is available if you put no arguments, and then you put one and the language, so you have GNO and Sol. You must have all the toolchain downloaded, and it will launch it. You just click on GNO Web here. It says there is no render functions, but it's normal because it is just code, but you can still execute it. And once clicks, you have access to it. There's a little readme to explain you what it does precisely. For Solidity, it is the same with Sol. Thank you for listening, and see you next time.